Now in this video, we are going to understand how we can find the minimum and the maximum element in a group of data item utilizing the property of a binary search tree. That is, the data item stored in the left is always less than the data item stored in the parent, which is again always less than the data item stored in the right. So how we can leverage this simple property to find the maximum and minimum element very efficiently. So the process is actually very easy, and if you look at this binary search tree on this screen minutely, you will realize that the leftmost node in this binary search tree, which is 11, is the minimum among the entire group of item. On the other hand, the rightmost element, which is basically 99, this is the maximum element in this entire group of item. So the algorithm is also significantly easy. So now let us try to understand the algorithm with an animation. So here in this Visualgo website, there are three different search. Hit the search, and there are find minimum and find maximum are here. So let's start with find minimum. What it does is, so it always, again, it starts with 41. So again, it start if the tree is already empty, that is if the root is null, then return empty. So it is just a condition for checking whether the tree is empty or not. Well, the tree is not empty, so it checks that if left not equals null. So now it is checking, since the tree is, or the root node is not null, there is something in the root node, then it is checking whether it has some data element in the left hand side or not. I mean the left hand side of this root or not. And if there are some item in the left hand side, that is left is not equals null, it will just come to the left hand side, the left child. Now again the same process repeats. It checks whether this node has some element left in the left hand side or not. Well, it has some element, and so it just go to the left. And now it's checking that whether it has any other element left after 11 or not. Well, no, it does not have anything, so it is just returning 11 because this is the leftmost element, and by leveraging the binary search tree property, 11 is the minimum element in the entire group of element. The same thing happened for the map to find the maximum element, but in the other direction, that is in the right hand side. So let's just see the animation quickly, what happens during the maximum element. So let me hit this find maximum, and so here you can see, so the entire algorithm is same, but instead of left, it is now checking right, and that's it. So what happens here? Here actually the program starts comparing, program starts from this root element, which is 41, and then if the right hand side is not null, then it moves to the right element. Then again at 65 it checks whether it has some element in the right hand side. Well, it has, so it again proceed to the right hand side. The same thing happened in 91 also, since it has 99 in the right hand side, so it move towards 99, and now it find that okay, after that it cannot proceed into the right direction anymore, so this is the maximum element in the binary search tree, and it returned the tree. return the element. So this is how you can find the minimum and maximum element in the binary search tree. And again, if you look at this orange trail in this animation, that is giving you how many different comparison have been done in this entire in this finding max process. So here again, it the entire binary tree has like 10 data items, but you can find the maximum just by finding only these fewer nodes, just by doing right. Only with these four nodes, traversing the four nodes, you found the maximum element, which is not possible in a normal array or normal linked list situation. So this is how binary search tree is making the find maximum as well as find minimum process significantly efficient by leveraging its L less than left less than parent less than right property.